All right. Good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already subscribed to the channel, leave a like, comment, and share. Now, in today's lesson, I am starting a playlist that will be on algebra and cryptography. And basically, I will be okay. The lecture will be broken down into two parts. So the first part of the playlist will have the RSA encryption. Okay. Then the second part we can talk about Elgamo's encryption system. Right. So encryption, I believe it's not a new word. Like just about keeping a message secret, right? And having someone maybe translate or decipher the message. So this is what encryption is about. So we will learn how to encrypt a message using the RSA encryption system and decrypt the message using the message that is in RSA. You learn how to decrypt that. So, but starting this playlist, there are a few things that you should know. So the first thing that we're going to look at in today's video is the modulo operation. Then we are going to talk about primes in the next video and the totient function. Okay, so primes and the totient function, then we have to seal it off with RSA encryption by hand. So see how we can encrypt and decrypt a message by hand using the RSA encryption. Then the application. So we apply this using Python. Application in Python. Okay, so that is the outline of this playlist. So let's get on with the modulo operation. And basically, I'll have this PDF. So there is a way that I could share it with you. You can send me a message. I will basically share the PDF as well with examples. So I'm putting it in a PDF. So the modulo operation. So the modulo operation, or I'll just put a link down so that you are able to download PDF as I am updating it. So the modulo operation. All right, so what is the modulo operation? Let me bring you up to speed. Let me take you back to maybe grade 1. Okay, if you have something like 10 divided by 3, how would you calculate this? For 10 divided by 3, you as a grade 1 would go maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then divide 10 into 3 parts. You would go 1, 2, 3. Okay, then you have a remainder, and you would write this as it goes there 3 times and leaves a remainder of 1, and you say over 3, right? So you would do something like that. Or what about 27 divided by maybe 5? Well, you would do the same thing, but if you were a smart kid, you would say maybe 10, 10, 5, or maybe you would just say 20 and like 7, something like that. So, but anyway, whichever method you used, maybe 10, 10, 5, and 2. So this adds up to 27. Then you'd say 5 goes there 2 times, goes there 2 times, goes there 1 time, and we have a remainder of 2. So you would write this as 5 times 2 over 5, something like that. And the idea is that when you multiply 3 times 3 plus 1, it should give you 10. 5 times 5 plus 2 would give you 27. So you would do this. Now, when it comes to the modulo operation, what we are interested in is the remainder, not opposite. So the modulo operation, just talk about how, or let me say it's just an operation for the remainder, and what we are interested in is the remainder. So if I said 3 modulo, let's say 10 modulo 3, what I'm interested in is the remainder. So it would be an expression written something like this. So it would be maybe 10 modulo 3. Okay? And this basically means, what do you get as the remainder when you divide 10 by 3? Okay, and we get 1. Okay, easy peasy. The other one is this one. How would we express this? 27 mod 5. Same question. So others will even put in brackets like that, but it doesn't make much difference. So same question they're asking you is, when you divide 27 by 5, what is the remainder? Well, we know the remainder is 2. So that is that, and you're done. Okay, so that is the modulo, right? I will show you how to say, now you are given a number, say you don't know the remainder, because these numbers we knew the remainder. So maybe you're given a number like maybe 27, all right, and you're dividing this by maybe what, 5. Okay, so you have 207 divided by 5. What is the remainder? Well, you could divide 2 by 5, and but the shortcut for this on your calculator, so you pull out your calculator, you will say 207, you divide by 5, right? Or maybe you could try it before I show you the way. You can pause the video, you try it, then we see the process, right? So you say 207 divided by 5, it will give you an answer. So let me say that is 207 divided by 5, 207 divided by 5. So it gives me about 41.4. So you don't have to write this, but I'm just writing for the sake of you knowing. So you have something like 41.4, right? So you have something like this. Now what you're going to do is, you're going to take note of the number before the decimal. So in our case, that is 4. So you will say 207 divided by 5 gives us this number. So, but we're subtracting from it the 41. Then we multiply everything out of 5. And this will give us the remainder that we're looking for here. Okay, so you just do this in all cases. So even try for 10 mod 3. So you see that it will work out, right? Then I'll show you an interesting property of the modulo operation. So we have 207 divided by 5. We know that when we punch this on our calculator, so we have to do everything on our calculator. So you see that it's giving you 41. So you just say minus 41. You have that number, then everything multiplied by the divisor, which is 5 in this case. So minus 5 is 5. So we get the number 2. So this gives us, okay, approach. Okay, so that is how you're going to compute. You're given a number like this, you don't know the remainder, they just say 207 mod 5. Just follow this process. You get the 207, you divide it by the mod. Then the answer that you get, you take note of the number before the decimal, you subtract from it the whole number, then you multiply by the mod, the answer. So let's try for 3 so that you see we're talking about again. So 10 mod 3. So it would be the same procedure. So you'd say 10 out. It would be 10 divided by 3. Oh, I see it's 3.33333. Right? So what I'm interested in is the number before the decimal. So I will say minus 3. Right? Hope you can see that. Gives me that number. Then I'll just say everything multiplied by mod part. So it was mod 3. So I'll multiply everything by 3. It gives me 1, which is the one that we have here, right? Same applies for 27 mod 5. You do the same thing. You get um, you first start by 27, divide by 5. Okay, it gives you 5.4. So I take note of the 5.4. I say minus 5. Okay, I just take the coefficient, so I get like 0.5. That, then everything times the mod part, which is 5, gives me 2, which is the 2 that we have there. Let me give you one more example, and I can go into some properties that we'll look at. So let me say 333 mod. Let me do 2 examples. Mod 2. All right, so you go by the same process. So you say 333 divided by 2 gives you 166.5. So you say minus 166. So what we're interested in is just the number before the we're interested in 166, so we say minus 166. So it gives me 0.5. I don't even have to write it out. Then I'll just multiply everything by the mod, so which is 2. So this gives me 1. Okay. Now, one property that you should know is that when the number here is smaller than number here, okay, when you have a number here that is smaller than the number here, the modular, you don't have to waste your time. Just get the number 3. Okay, so using the same formula, suppose you have 26 mod 27, could be maybe 220, whatever. So it will always be number 26. Okay, to be, so this actually is 3 mod 4. Okay, and this is actually 26 mod 270, right? So something like that. So let's look at this. So you do the same thing. So if you get the same number, it means you are modding it again. So modulo is an inversive process. So you have 3 mod 4. So that gives you about 0.7. So we see that the number that is in front here is 0. So we say 0 times the modular, which is 4. So modular is 4. So we see we get back the same answer. So that is one property of moduli. So 26 270 will be 26 mod 270. And sometimes they'll just write it as 6. So, but 26 mod 270 is 26 mod 270. Then the other property that you should know is that if the number is divisible, the mod will be 0. Okay, so let's say 25 mod 5. Okay, we know for a fact that 5 goes into 25, so there is no remainder that is left. So when we try our same formula, so we're saying 25 divided by 5, so it gives us a number 5. So we'll say, well, what we're doing is we are subtracting the number before the decimal, and the number before the decimal is 5, so we say minus 5. So it gives us 0. So say we don't care, then we say times 5 again. So it will still be 0. So the remainder is 0. Same applies to maybe 333 mod 3. Okay, I'll give this example. 333 mod 3. What you do again is you say 333 divided by 3 gives you 111. So 111 is the number before the decimal. So you say minus 111. Gives you 0. 0 times 3 will give you 0. Okay, so this is what it is. Now, they are big numbers. So suppose you have a number like 2 to the power, let's say 4, 7, 20. Now, doing this by hand will be very tedious. And if you're using calculator, I think it would bring like math error or something. So let's try 2. What is 2? 2 to the power 4747. So for me, that is using to the power. Like the number is so big that I have an invalid input here. So same applies for you, but you can find the the mod of this. So what you do is you use the Chinese theorem. So what you do is you break it down. So you say this 2 can be simplified as 2 to the power something like 10, then the power 470 mod. So you could do something like that. So you're just breaking down. So you know that 10 times 470 will give you back that. Then what you do is you compute 2 to the power 10 mod 20. So I can do that on my calculator now. So I would say 2 to the power 10 divided by 20. So it gives me like 51.2. So what I'm interested in is the number before the decimal. So it's 51. So I'll say minus 51 minus 1 gives me that, then times 20. To the power 10, 1 times 20. 20, I get 4. So meaning that I've not gotten the final answer. What I've gotten here is 4 raised to the power 470 mod 20. Okay. I could further reduce this. Maybe I could also say 4 to the power 10, 4 to the power 10, then the power 7, because I know that 10 times 47 will give me 470. So again, I say mod 20. So how do you do this? Again, you go back to your calculator. So you say, well, I have 4 to the power 10, okay, which is that number, divide by 20. Oh, I have that number, so I need to take note of that. That is 52428. 5 get that number, then everything final answer 20. So I get 16. So 16 the power 47 20. I could further decrease this. Okay, I could even do something like this. I could do, let's say, well, I know that this can be written as 16 the power maybe 40 plus 7 mod 20. Okay, write that. Then I know that when I have power that is summing the powers, I have a base that is summing the powers. This can be written as 16 the 40 times 6, 16 to the 17. Okay, so but I can do that. But I also know that what is 7 times 7? It's 7 times 7, it's 49. Okay. What number does, maybe do we have 7 divided by 3? All right, so I thought it was something. All right, but you could do this, and basically you could say 16 to the power 40 like that times 16 to the power 7 mod 20. So this part is still being applied to the mod part. So you would say, well, what is 16 to the power 40? You can compute that on a calculator. 16 to the power 40, a small number, Oh, it's a big number again, so I still have a long way to go. What about maybe 16 to the power, I would say to the power 10, so that I can break it down. I would say 16 to the power 10, then everything to the power 4 times 6 to the power 10 to the power 7, right? Mod 20. So we are still going. So we will do 16 to the power 10 mod 20, then 16 to the power 7, 20, right? So we'll do 16 to the power 10, 16 to the power 10, power 10, that is that number divided by 20, gives me that. So I need to take note of that. Well, I don't have to write it. I can just say minus. Oh, sorry. That is 5. Yeah, I have to take note of it. So I'll just 5, 4, 9, 7, 5, 5, 3. So it gives me that. So times mod 20, 20. So it gives me 16. I'll write my 16 down here. So it still gives me 16. This is 16. 16 power 4. Okay. Then I could do the same for 10 to the power 19. I think this will be 10, 7, 10 to the power 7. Get that. Okay. 10 to the power 7, I get that number. Okay. You see that there is no, oh, divide by. Okay. So we have that number. That number. So we take note of the number before the decimal. So that is, let me write it down. All right, so let me write minus 1, 3, 4, 2, 1, 3, 2, 1, 7, 7, 2. Okay, it gives me that. So times the mod part is 20, so times 20. So it also gives me like 16. Okay, so 16. So I'll write it here as 16. Then we have the mod 20 here. Well, this is like almost a small number now. I can bring them back. So this is 16 to the power 4 plus 1, which is just 16 to the power 5 mod 20. Okay, so I think we are close now. We can just punch that directly. Say 16 to the power into the power 5. Power 5, it gives us that, divided by 20, gives us that. So we can take note of the number, which is 5, 2, 4, 8, 2, 5. 5, 2, 4, 2, 5, 2, 5, 2, 4, 2, 5, 2, 5, 2, 2, 8, 2, 2, that times 20, modulo part, get 16. Okay, this is 16. And here. So that is how you deal with big number. So you have a big number mod something small, you have to take it down kind of slowly like that. So we had this number 2 to the power of 4,720. So we broke down this. When you punch it directly on your calculator, you are going to get an error. So we broke it down and went with it step by step. So we say 2 to the power 10. Then we say mod 20, it gave us 4. And 4 to the power 270. So we simplify further. So kept on decreasing until we got to 16 as our final answer. All right, so that is about it for the modulo for today. Then see you in the next video. Have a great evening. Don't forget to subscribe.